afternoon, everyone. I've been talking to the TAs, and there were a couple of concepts that we all felt needed some additional clarification. And so I've made this short video to go through a couple different concepts in a little more detail. I hope this is helpful to you, and please keep any questions and confusions that you might have about the material coming. We will do our best to address any lingering questions or concerns that you have. So I'm going to quickly today go through four basic concepts. One is the connection between sampling and study design. Another is why we can't estimate a risk ratio in a case control study. I'm going to go through question one on the homework because the TAs indicated that there was some kind of widespread issues with that question. And then I'm going to talk a little bit about both the interpretation of the confidence interval and the interpretation of measures of association and what should be included in that. So let's start with the connection between sampling and study design. Okay, so let's start with sampling. So leaving aside any kind of issues related to study design, there are basically two different ways that we can take a sample from the population. One, the sampling can be random. And when we talk about random sampling, we mean that each individual in the population has an equal and independent probability of inclusion in the sample. So the sample needs to be enumerated, which means we need to be able to identify everyone in the population, and then we need to be able to in some way assign each person a probability of selection into the sample. Those probabilities should all be equal and independent, and by independent I mean that one person's probability does not depend on the selection of another. So for example, when we talk about independence, you don't want the probability to change once a person is selected. So imagine that you have 10 M&Ms in a jar. 5 of the M&Ms are brown and 5 of the M&Ms are red. So at the start of the selection, a brown M&M would have a 50% probability of being selected, and a red M&M would have a 50% probability of being selected. Once you select one, let's say you select the red M&M, then the probabilities for the M&Ms that are remaining in the jar change, right? Because now there are fewer red M&Ms than brown M&Ms left. So the probabilities would depend on the selection of the first M&M, whether that first M&M was brown or red. And so the probabilities would not be independent. So we do the same thing when we're taking a random sample from a population. Once each individual is selected, the remaining probabilities shouldn't change. And when we do such a random sample, the resulting sample should be, as sample size increases and on average, representative of the population of interest. That is, the characteristics in the population of interest, the distribution of those characteristics should be the same in the sample as it is in the population. If the population is 50% women, the sample should be 50% women. If the population is 30% people under the age of 30, then the sample should be 30% individuals under the age of 30, etc. A purposive sample, on the other hand, is not random. The individuals are selected into the sample based on specific characteristics of interest, specific eligibility criteria. For a lot of different reasons, they might be selected based on their disease outcome of interest. They might be selected because they have a certain exposure of interest. And typically, a purposive sample we conduct to answer a causal question about the effect of one phenomenon on another. So if our question is, does smoking cause lung cancer? Or does exposure to a certain toxin influence brain cancer? We don't need a representative sample of the population to answer that question. We need a sample that's selected in such a way that we have exposed and unexposed that are comparable on all factors that cause disease other than the exposure of interest. And we've gone through this in detail in the chapter and in the lecture, so I won't belabor this point, but the bottom line is that sampling can be random or purposive, independent of the study design. So here's just some examples that I came up with. Which of the following, are the following random or purposive? So first, you take 1,000 individuals exposed to radiation, and 10,000 individuals exposed to radiation, and 10,000 individuals not exposed to radiation, and you follow them for 5 years. The incidence of thyroid cancer is estimated in both groups. So that would be a purposive sample. We're not selecting individuals in a random way such that the distribution of exposure to radiation is the same in the sample as it is in the population. Instead, we're selecting, by design, 10,000 individuals exposed and 10,000 individuals not exposed. And this design is an excellent design if we're interested in the causal effect of radiation exposure on thyroid cancer. We don't need a representative sample in order to answer that question. So this is a purposive sample. So second, we have 500 people with HIV that are sampled from primary care clinics and 500 people without HIV which are sampled from those same clinics. Individuals are each interviewed about condom use in the 2 years preceding their diagnosis. Is this random or is this purposive? Again, this is a purposive sample. We're not selecting individuals at random in order to estimate the prevalence of HIV. We're specifically selecting 500 people with and 500 people without the outcome of interest. We're doing that on purpose. It's purposive, so that we can answer a causal question about the effect of condom use on HIV. Finally, we are interested in estimating the prevalence of asthma among New York City school children. In each grade, in New York City, 20 children are selected on the basis of a random number generator from school enrollment records. So this is an example of a random sample. And the reason that we would do a random sample is, again, to estimate the prevalence of asthma or estimate parameters of interest where we want to know the population prevalence. But we don't have enough resources to interview the whole population, so we take a sample. We're not interested in necessarily answering a causal question. We want to estimate parameters from the population within our sample. So that's sampling, independent of study design. Now, when we go to study design, there are three main common study designs in epidemiology. These are cohort studies, case control studies, and cross-sectional studies. So all of these studies could employ either random or purposive sampling, right? So you could do a representative sample, a random sample of a population, and then follow them forward in time to estimate who gets disease and who doesn't. So it would be a cohort study with representative random sampling. You could do the same thing in a case control study if you wanted, and the same thing in a cross-sectional study. You could also do a purposive sample where you select 10,000 exposed, 10,000 unexposed, follow them forward, and that would be a purposive design that was a cohort study. So again, purposive random, that's one consideration. Design, cohort, case control, or cross-sectional is an additional separate consideration. So each of these designs can have a different sampling procedure. However, cohort and case control studies are almost always purposive. We just don't have the resources to do a random sample and follow them forward in time. And cross-sectional studies are almost always random samples because we almost always conduct cross-sectional studies in order to estimate population parameters of interest. So relatedly, cohort and case control studies, we most often do them because we're trying to address causal questions. What are the causes of cancer? What are the causes of these different outcomes? Cross-sectional studies really aren't done to estimate causal effects of exposures on outcomes. Usually they're done to estimate the prevalence of different health indicators. Usually we would just want to know the burden of disease in populations, so we do a cross-sectional study. So, in summary, sampling is the process by which we abstract a group of individuals from the population of interest in order to measure and observe a characteristic of interest, and this sampling can be random or purposive. And to go back to that for a second, however, study design, whether random or purposive, can follow people forward in time, can be on the basis of disease, or can be at a single point in time. So study design and sampling are two different components of how we put together the study. And if there are additional questions about that, feel free to reach out to me or Dr. Galea or to the TAs. So next I wanted to go through why we can't estimate a risk ratio in a case control study. And to do this, I'm going to go back to one of the examples that we used in our slides, which is where we did a case control study, and the research question was, is smoking cigarettes during pregnancy a potential cause of offspring ADHD? To do this sample, we collected 500 children who were seeking care for hyperactivity. For each child with hyperactivity, we selected 2 children of the same age at the same physician office who presented for a routine well visit. I'm going to have some iced coffee. Okay. So, by design, we're doing a case control design, and we decided that we want 500 children with ADHD. We also decided that we wanted 2 controls for every one of those children, so we have 1,000 controls. So now, let's look at our 2x2 table. Here on the column that says disease, you can see that the total is 500. In the column that says not disease, the total is 1,000. So what is the quote-unquote risk of ADHD in the total sample? Well, we know that the risk is the number of diseased individuals, or the number of people with the outcome, over the population at risk. So in this study, it would be 500 over 1,500. That's the risk of ADHD in this sample. So it would be 1/3. But does that 1/3, does that correspond to a population parameter of interest that we care about? No. Because we decided at the beginning of the study that there were going to be 500 kids with ADHD and 1,000 kids not with ADHD. So the fact that 1/3 of the kids in our sample have ADHD does not correspond to any risk that we actually care about in the underlying population of interest. It was set by the design of our study. So for that same reason, if we did conditional risks, such as the conditional risk of disease among the exposed, 300 over 803, or the conditional risk of disease among the unexposed, 200 over 697, again, those parameters don't have any relation at all to population parameters of interest. So the ratio of those two risks also would be meaningless. You could estimate that parameter, but it would have no interpretation at all. So risks in general are not estimable in case control studies when we decide a priori how many diseased and non-diseased people there will be. And so it was through, all we can estimate then is the probability of exposure among the diseased. And Kornfeld in the 1950s and numerous epidemiologic methodologists since then have determined that the odds ratio is actually a really good measure of association for these circumstances, because the exposure odds ratio equals the disease odds ratio. So that we can estimate the odds ratio in a case control study and actually have interpretation value to that because of the mathematical equivalence of the exposure and disease odds ratios. So I hope that answers the question of why we can't estimate a risk ratio in a case control study. It's because we set the prevalence of disease at the beginning of the study.